So the appearance under a microscope. The ferrite will appear white. The pearlite is a blend of the ferrite and cementite. The pure pearlite line, 0.8% carbon, is where the ferrite and cementite are perfectly balanced. Remember that it looks like ridges, and the dark lines are cementite, where the white area is ferrite. Figure 10.4 that's in your book, ferrite and steel samples. Remember again that ferrite appears as white patches and the black patches are pearlite. Example A is 1020 steel ferrite with some pearlite. Example B is 1015 steel viewed at 700 magnification. Figure 10.5 is a pearlite photo of 1095 steel, and they look like rows of a plowed field. Figure 10.6 is the ferrite pearlite structures that are in your book, and it gives you the different carbon contents of what that looks like under 1000 magnification and a 500 magnification. It is a martensitic microstructure. And remember, martensite has needle-shaped grains. And this has been under a microscope at 1220 magnification. Figure 10.8 in your book. This is the first time that we have talked about bainite. Bainite is a crystalline microstructure that can be found in steel. Bainite forms when steel is cooled slower than the rate required to form martensite, but faster than the rate that would be required to form pearlite, or another slower cooling rate crystalline microstructure. Bainite is typically considered very hard and brittle. Bainite is a combination of ferrite and cementite. The amount of cementite and ferrite formed depends on the carbon content of the steel and the rate at which it was cooled from the critical temperature. If the carbon content is lower, there will usually be less cementite present. Higher amounts of carbon in the steel will allow for higher amounts of carbides mixed in with the ferrite.